Hi folks, I may not be here either physically or mentally depending on what time of day this is. Now yesterday we covered how to deal with certain angles inside of a circle. Central angles, which are found at the center of the circle, and inscribed angles, which are found on the circle itself. Now today we're going to look at two other random kinds. One would be an inside angle, because it's floating around somewhere on the inside of the circle. We're going to take a look at outside angles, which is when the vertex of that angle is floating around somewhere beyond the ring itself. We're going to take a look at the relationships, we're going to come up with some rules, and then we're going to practice what we have. So let's start with an example of an inside angle. Now an inside angle is an angle that's going to end up somewhere inside the circle. It's just not at the center, okay? So it's floating around anywhere else inside of the circle itself. Now here, I have an inside angle equal to 124 degrees, okay? And this intercepted arc equals 168 degrees. So notice that these measures are not the same. This is not like a central angle. Now, this top arc is 80 degrees. These two arcs here are called opposite arcs because they're on opposite ends of the circle. Duh. Now, I want to show you a unique relationship here. If I were to take that angle, 124 degrees, and to double it, what you would end up with is 248 degrees. If you were to take these two arcs and to add them together, what you would end up with is also 248 degrees. Notice how those are the same. It's going to work out that way every single time you have an inside angle. If you have this angle here, you can double it. And then you look at the two opposite arcs. And if you add those two arcs together, you'll get the same thing as two of these angles. So we could turn that into a formula. Now this is the way that most folks are going to teach it to you. But I like to do it a little bit differently, and that is this. And it's going to work that way every single time. Now vertical angles are two angles that are on opposite sides of the vertex. Now why is this important to us? Easy. Vertical angles are the same. So if this angle is 124 degrees, then so is this angle here. Now, these two angles that are adjacent to one another because they are side by side have to add to give us 180 degrees. They're supplementary because they are on a straight line. So if this is 124, I can subtract it from 180 to find that this angle here. Now, these two are vertical angles. So this angle is also 56 degrees. Now let's say what I have here, two arcs. Okay, this left side arc is 72 degrees and this right side arc is 40 degrees. And what I ask you to find is this angle here. Okay, well that's an inside angle, which means right now if I take two of these, that's going to give me the exact same thing as adding these two arcs together. So now if I continue this, and that's equal to two of those inside angles. So now just divide both sides by 2, and I find that that inside angle is equal to 56 degrees. That means that its vertical angle on the other side of the vertex is also 56 degrees. I can complete this by saying, well, 180 minus 56 will give me this angle. So I end up with, again, my 124. And if that top angle is 124 degrees, then this bottom angle is also 124 degrees. All from identifying that two of my inside angles is the same thing as adding my big arc to my little one. Again, two of my inside angles, taking the big arc and adding it to the little one. Wow, you can see my shirt. I guess I'm getting fat. Now this time, what if what I'm looking for is the arc? So I give you that this inside angle is equal to 108 degrees, which also means that this vertical angle is 108 degrees. Now, if I want to figure out the relationship here, I look at those opposite angles, here at X and here at 116. Now, if I take these and do the same relationship, two of my inside angles will give me the exact same thing as adding these two together. All right, so 2 times 108 is 216. So 116 plus something is equal to 216 degrees. So by just subtracting the 116 from both sides, what I find is that the measurement of my missing arc is equal to 100 degrees. Okay? But it was all by looking at that original relationship. Two of my inside angles will give me the exact same measure as taking the big arc and adding it to my little one. All right, here's my curveball, so I hope you're ready. I'm giving you that this top left arc is equal to 112 degrees, and this bottom right arc is equal to 104 degrees. But I want this angle, X. Now there's a problem here. That's an inside angle. So in order to find this, I can do it one of two ways. Now the way that's going to make sense first is to say, well, I've got two opposite arcs. So I could find these inside angles. And if I know what these are, they're supplementary with this adjacent one, X, meaning that X plus this angle will add to give me 180 degrees. But I got to figure out, well, what is this thing first? Okay, so I look at the two opposite arcs. I've got 112 and 104, and if I add those together, I'm going to get two of these mystery angles here. Two of those mystery angles are going to equal the same thing as my taking my big arc of 112 degrees and adding my little arc of 104. Now, if I add these two things together, I'm going to end up with 216. But that's two of my inside angles. Now, if I divide both sides by 2, what I end up with is that one of those angles is equal to 108 degrees. So I know that this angle here, which is congruent to its vertical angle, equals 108 degrees. Now remember, these two are supplementary. If they're supplementary, these two add to give me 180 degrees. X, which is also equal to this vertical angle, is equal to 72 degrees. Now that was a little tricky, but not so much. But here's the catch. There's an even easier way. Notice here's the center. Okay? Now I didn't really do the best job, but watch this. What if I told you that this line straight down the middle, okay, this line straight down the middle here, was actually a diameter? Now, if I tell you that that's a diameter, that means that this part here was really a semicircle. Okay, all the way around is a semicircle of 180 degrees. If this is 112, then right now, this arc is what I need to have 180 degrees. Okay? Now what happens if my intersecting lines or segments give me a vertex that is now outside the circle, anywhere outside of the ring? So here in this situation, I have an outside angle that measures 43 degrees. Now again, it is outside the circle. Now if you follow along the segments, they intercept two different arcs. One here that's 25 degrees, and another one here that's 111 degrees. Now, just like the inside angles, I'm going to show you that there is a relationship between all these that we see. So if I take two of these 43-degree angles, what we end up getting is 86 degrees. Now, just like with the inside angles, I'm going to use these two intercepted arcs. With an inside angle, I had to add the two together. This time with an outside angle, I'm going to subtract them. Now, if I take 111 and I subtract 25, you know what I get here? I got the same exact thing. If I double this angle, I'm going to get the difference, again, the difference between the two arcs. So here was my pattern. So outside I subtract, inside I add. Again, outside I subtract, inside I add. All right, so in this example, I'm giving you that these two intercepted arcs are 113 degrees and 37 degrees, okay? What I'm trying to find is this outside angle, x. Now, the relationship for an outside angle is that if I take two of these angles, I should get the exact same thing as the difference between these two arcs. So I take 113 and I subtract away the 37. Now if I work this out, now in this example here, I see that I have an angle outside of my circle and that this angle measures 14 degrees. Now if I follow these segments straight through the circle, okay, secant segments, because they intersect two times, one of my arcs is 31 degrees and the other arc is x degrees. I need to find this missing arc. So remember, if I have an outside angle, if I take two of those angles, that's supposed to give me the exact same measurement as the difference between these two. Now, this is key. It's always the big arc minus the little one. Again, it is always the big arc minus the little one. It is always the big arc minus the little one. The big one is furthest away. The little one is closest to the angle. Okay, so see that right there. It is always the biggest minus the smallest. So 2 times my outside angle of 14 degrees would be the same thing as my big arc minus my little one. So now I'm going to solve for x. 2 times 14 is the same thing as 28 degrees. So my arcs are supposed to be 28 degrees apart. So now, if I add the 31 over here to the other side, what I find is that my missing big arc was exactly 59 degrees. So again, what did we find? We found that this big arc here was exactly 59 degrees. So how far apart are these? 28 degrees. What's 2 of my outside angles? 28 degrees. This thing checks out. Now here, I have 2 tangent segments because they only touch the circle at one point. Again, a tangent segment because it touches the circle at one point. Now, this outside angle is what I'm trying to find. And I'm told that this outer arc, this big arc, is 225 degrees. Find the angle. Now here's the deal. I know that if I take 2 of these angles, that's supposed to be the same thing as the difference between these 2 arcs. 225 minus something. Okay? 225 minus something. So the question is, how do I figure out this smaller arc? Well, I need you to remember something. On a circle, if I were to add up all the central angles, I got 360 degrees. Also, if I were to add up all of the arcs the whole way around the circle, I should also get 360 degrees. So let's kind of break this for a minute. Here at the tangent point and here at the tangent point. Now I tell you that this outside arc is 225 degrees. What is left over here if I need a full 360 degrees the whole way around? So in order to find this arc here, all I would need to do is to take 360 and to subtract away the 225 I see up here. Now, what I find I have is 135 degrees. Okay? That's the measurement of my small arc. So now it's time to come back over. 2 of my outside angles equals the difference between my big and my little arc. So again, 2 of my outside angles equals the difference between my big and my little arc. Well, now I can solve this. 225 minus 135. How far apart are those? Well, here it's 90 degrees. Well, that's all great, but 90 is 2 of my outside angles. I want just one of them. So what I find is that my outside angle was exactly 45 degrees in measure. Okay? But again, what was the curveball? I only gave you one arc. But remember that when you add all arcs together, you will always get 360 degrees. All right, so let's review. We had 4 different types of angles when dealing with the circle. First, we had central angles because they were found at the center. And I know that a central angle is equal to its arc. So I know that the arc is also equal to its central angle. Second, I knew about an inscribed angle found at the point on the circle. Now, an inscribed angle is half of the arc, which means that an arc is twice as big as that inscribed angle. Now, third, I had an inside angle because it was floating around somewhere inside the circle, okay, like here with the 65 degrees. Now, if I were to double that inside angle, I would find the sum of the 2 opposite arcs, okay? So if I know those 2 arcs, add them together and divide by 2, and I will find the measure of that inside angle. Lastly, the fourth one had to deal with these outside angles because the angle was found outside the circle. Now, if I take this and double it, I'm going to find the difference between these 2 intercepted arcs. So on the flip side, if I know the big arc and I know the little arc and I find how far apart they are, I subtract them. Then I'm going to find exactly double my angle so I can divide by 2 and find what this should be. I cannot emphasize enough. Inside, add, outside, subtract. Inside, add, outside, subtract. Third time for the dense folks in the room. Inside, add, outside, subtract. All right, folks. That's really all there is to it for these angles. So I want you to take what you used and I want you to start on page 7 of your green homework packet. Again, page 7 of your green homework packet. The first 4 are inside angles. The last 3 are outside angles. If you manage to get finished in class, go ahead this weekend and start on your quiz review. Again, Quiz Tuesday. You just remember, everything about this lesson is about to come, wait for it, full circle. I'll see you again on Monday.